This is a video for the last problem that we're doing on page 40, number 8. Otto Emissions is driving his car at 25 meters per second. Otto accelerates at 2 meters per second squared for 5 seconds. Otto then maintains a constant velocity for 10 more seconds. Determine the distance Otto traveled during the entire 15 seconds. So, it's telling us that we ultimately have two separate accelerations. We have our first acceleration, which is 2 meters per second squared, and then we have our second acceleration, which is 0. We're going to maintain a constant speed. So we're going to set up our equation. I've already got mine on the board. Take some time to write yours out real quick. Make sure you're getting organized. So then we'll draw this out real simply. Box, that's a car going this direction. So we're starting at 25 meters per second. Then we're going to have some final velocity after we accelerate at 2 meters per second squared for 5 seconds. It's giving us a lot of information. That's gonna be really nice. So first, 25 meters per second for my initial velocity. My final velocity, I don't know it. My acceleration is going to be 2. My time is going to be 5. My time is going to be 5. There we go. So, xi, I choose where it is, 0. So, the first problem, I can go ahead and figure out my displacement. So, we're going to plug in our S formula. S equals xi plus vit plus 1/2 at squared. And so, xi is going to drop out. Vit, that's going to be 25 times 5 plus 1/2 of 2 times 5 squared. Okay, so it's going to be 25 times 5 plus 0.5 times 2 times 5 squared. That's going to be 150. So our S1 is 150 meters. But we still have 10 more seconds that we need to account for. So how are we going to do that? Well, we need to know our velocity for our second part. So we're actually going to set up a second set of variables. So in our second set, we're going to say we're finding S again. We're starting from xi being 150 meters. And so once we add that on, this will end up being our S total, so we won't have to worry about adding those together later. Our initial velocity, well, our initial velocity here for the second part is going to be our final velocity over here. Let's find that real quick. So we've got A is equal to Vf minus Vi over T. If we rearrange that, we end up with Vf is equal to At plus Vi. So A times T, that's going to be 10. 2 times 5 is 10. Plus Vi is 25. So our Vf is going to be 35 meters per second. So put that in for our Vf. And our Vi for part 2. Meters per second. Final velocity. Well, we're not changing our velocity. It's going to stay constant, so that's going to be the same. 35 meters per second. And our acceleration, because our velocity isn't changing, is going to be 0. Our time is given to us is going to be 10 seconds. So setting up our S formula one more time, S equals xi plus vit plus 1/2 at squared. Well, acceleration is 0. That's going to drop out. Xi is 150. So that, for once, is going to stay. It's going to make it a little bit simpler. So vi times t, that's going to be 35 times 10 is equal to s. So 35 times 10 is 350. 150 plus 350 is going to be 500. Nice clean numbers here. So our S total is going to be 500 meters. There you go. And that's that.